A very good evening. So we are from Group 8. We have been tasked to present a report titled Optimization of Minima and Maximum Problems. So here our group member Dinesh, myself, Chan Zinvi and Muhammad Amirul Ashraf. Introduction. So I'll be explaining the introduction. Optimization is a branch of applied mathematics which can be very useful to design many kind of applications. So as for example, manufacturing and also engineering. So this kind of minima and maximum problems can be used to obtain the stationary points and their nature. So maxima is the highest point of the curve within the given range, while minima can be said as lowest point of the curve. So the combination of minima and maxima will form extrema points. So without using a concept of calculus optimum points, which can be obtained or identified by using specific examples such as calculating vertex of parabola. Instead, we can also use the graph of functions to find local maxima and minimum. There are some objectives to find this local maxima and minima. First is to identify and determine global or local maxima and minima. Second, to define absolute extrema and local maxima, and to explain and determine how the critical points of a function over closed interval. And lastly, to identify the critical points which are used to describe and locate absolute extrema and over the closed interval. So next, I'll pass to Zinvi.
So I will explain the main point one of the optimization of maxima and minima. The basic idea is that the optimal value of the differentiable function fx, which is maximum and minimum value, can be obtained when the derivative is 0, which means f prime x equals to 0. And to determine the nature of stationary point, we can calculate the value of second derivative. So second derivative of fx at the point, fx has a stationary point at x equals to a, so that f prime a is equals to 0, and the function fx has a local maximum x equals to a provided second derivative fa equal to 0 and second derivative fa is smaller than 0, and the function fx has a local minimum at x equals to a provided f prime a equals to 0 and second derivative fa is bigger than 0, and the function fx has inconclusive at x equals to a provided f prime a equals to 0 or f second derivative fa equals to 0 and second derivative fx equals to 0, which indicate the second derivative fx doesn't exist. So I will pass to Amiru.
Okay, so the main point tu, okay, figure 1.5 show the location of global maximum, local minimum and global minimum. Every global extreme is considered as local extreme, but there are local extreme that are not equal to the global extreme. So the definition of a global maxima and minima is if fs has a global maximum at x equal to a, so fa and fs for all value of s in the domain of fs is fs has a global minimum at s equal to a if fa and fs for all value of s in the domain of fs. And lastly, for the fa has a global extreme at s equal to a if fa is a global maximum or minimum. So here is a example of the graph, and then I will pass it to the Chanzivi to show the example.
So this is one of the example to show us how to use the optimization of maxima and minima to calculate the maximum area of this garden. So first we can deduct two formula, and we can use the first derivative to calculate the value of x and y, and we use the second derivative to determine the value is maximum or minimum. So we can know that the maximum area of this garden is 1,250 meters square.
So next, we use this application in daily life, such as radiation therapy and also chemotherapy. So to study this is a very treatment. It is a treatment affects a patient or not. So from the graph, we can find the initial value of tumor, which is 0.5, and it is decreased to 0.2 cm cube. So using this calculation of derivation, we know that the change in tumor volume is a graphing that derivation allows to analyze the rate of change in tumor. So besides that, optimization of maxima and minima also used in business operations to maximize the profits. So for example, we can express it to find a profit in the number of units. So yes, that's all from us. Thank you.